Hello students, in this video we are going to discuss about the balancing of redox reactions. That means if a redox reaction is given to us, how we balance it, and that we have to do by a method that is oxidation number method. If a redox reaction is given and the medium is given acidic at the time, how to balance a redox reaction, that we are going to discuss here. For this we have to use some of the steps which we'll be discussing simultaneously with an example. So let us take one example. Like this example is given, MnO4 negative plus SO2 give rise to Mn2 positive plus HSO4 negative. How to balance this redox reaction, and the medium is given to us, that is acidic. So as I told you, there are some steps. So directly we'll be discussing these steps with this example. First, you have to write the correct formula for each reactant and product as it is already written here. So first we are writing this, and next is we have to write down the oxidation number for each here. So we'll be starting first writing the oxidation number. Oxidation number of Mn in MnO4 negative, when you find it out by the using of X method, which we have already discussed. So when you find it out, you will be getting the oxidation number for Mn in MnO4 negative, that is plus 7. So better write it on the top of it with the pencil, as I written here with the red color. So you write it with pencil. Next, because oxygen here, it is in the oxide form, it is -2 oxidation state and it is not changing here, therefore no need of writing the oxidation state of O here. But for sulfur, the oxidation state in SO2 is +4, so better write it on the top of it as I written here. Next, for Mn2 positive, the oxidation state of Mn in Mn2 positive, because it is an ion, therefore for an ion its oxidation number is nothing but it is equal to its charge. So +2 is the charge, therefore the oxidation state of Mn in Mn2 plus is +2. So better I am writing once again here. So don't get confused here. +2 is the oxidation state, that is nothing but it's equal to its a charge. Next, the oxidation state of sulfur in HSO4 negative, when you find it out by using the X method, you will be getting +6. So that is the second step, that is write down the oxidation number for each in the reaction, so that better make the use of any other color pen or pencil, so that you will not be able to confused with the overall charge with the oxidation state, because here there is one negative charge, here it is +7. So if you are writing the same color, it will be get confusion here which one is the charge here. So better, as I written here, I have used different color, so better you make the use of pencil for writing the oxidation number for each. Now that is the second step. Third step, here we have to see that from left hand side to right hand side, what is the change in the oxidation number, that is from the reactant to the product side. What is the change in the oxidation number? Is it is increasing or decreasing? So when you look at the oxidation number of Mn, that is in the reactant side and the product side, better highlight in this way by making the use of arrows like this. So the oxidation state of Mn, that is +7, the oxidation state is changing from +7, that is this value, +7 to +2, that is from left hand side to right hand side. The oxidation number for Mn is changing from +7 to +2. That means it is a decrease in the oxidation number, that is from +7 to +2. That means the value is decreasing. So if the value is decreasing, that is nothing but called as a reduction. that is oxidation number is decreasing, therefore it is a reduction reaction. Now in this step you have to identify that how much it is decreasing per atom. That means plus 7 value, it is decreased to plus 2. So when you find it how much it is decreasing, that is it is decreasing by 5 per atom, because here there is only single atom on the right hand side and the left hand side. Therefore for per atom there is decrease by 5. Therefore you have to mention it as it is, how I mentioned here. Therefore there is a decrease in the oxidation number by 5 per atom, that is plus 7 to plus 2. How much is the decrease? That is the 5 is the decrease. Similarly we'll be doing for the sulfur also. Therefore sulfur here, that is from the reactant to the product side, there is a increase in the oxidation number, that is by 2 per atom. Here also there is a single sulfur and here there is single sulfur. So therefore for per atom there is a increased by 2, because the value oxidation number is changing from plus 4 to plus 6. That means from here to here the oxidation number is increasing by 2. That is we have written here increased by 2 per atom. So this is what the third step. First step, what is the first step? You have to write the correct formula for each reactant and product, that is already given in the question. Next is you have to write down the oxidation number for each, that we have written here. Oxidation number for each we have to write. Better make the use of different color. Next you have to, in the third step you have to identify how much is the decreased and increased, that is for per atom. Now the fourth step, in the next step, that is equalizing the decrease and increased by multiplying with a suitable number. That is important here. Here there is a decrease by 5, here there is increase by 5. That means one number is 5, other number is 2. How we can equalize this number? We have to multiply with a suitable number so that we can equalize the increase and decrease. So how we can equalize? Better we can multiply 5 with 2, so we'll be getting 10. And in the next case, because there is 2, so better we will multiply with 5, so we'll get 10. So that means equalizing the increase and decrease by multiplying with a suitable number. So that means here 5 and 2 numbers are there. How we can equalize it? That is multiplying with a number, so that we'll get equal number. That is just a mathematical concept here. So here there is decrease by 5 per atom, and the other one is increase by 2 per atom. That is 5 and 2. How we equalize this one? That is multiplying the 2 with 5, so that will be getting 10. And in the case of decrease, because there is decrease by 5 per atom, we need to equalize it with the increase, so we have to multiply with the 2. It's very important here, that is equalizing, we have to multiply with a suitable number. So here 5 and 2 we have multiplying in order to equalize the increase and decrease. So after doing this one, the next step is write the equation once again, so that we can write down the balancing more comfortably. So next here, what the number you have multiplied for equalizing, that number should come in the stoichiometric coefficient. That means here MnO4 negative, that means it is the value is decreasing by 5 per atom, but for equalizing we have multiplied with the 2. So that number should be taken in the stoichiometric coefficient. And similarly here 5, that is for SO2, that you can see here this line. So that 5 you have to write it in the stoichiometric coefficient here. So For MnO4 negative, that is a decrease by 5 per atom the oxidation number. Therefore, we have multiplied with 2. Therefore, that 2 should be written in the stoichiometric coefficient for MnO4 negative. Similarly, for the SO2, there is increase by 2 per atom. Therefore, we have multiplied with 5 in order to equalize. So, that 5 which we have multiplied here for equalizing, that number should be taken in the stoichiometric coefficient here. So, that is the next step. So, what the number you have multiplied for equalizing, that number should be taken on the stoichiometric coefficient for the same. Next step, here we have taken a stoichiometric coefficient on the left hand side, but we have to balance the right hand side. So what the number we have used here, on the basis of this we have to balance the right hand side, because left hand side we have done it, we have to do the right hand side. So the next step is balancing all the terms except oxygen and hydrogen. That means hydrogen and oxygen, no need to balance it now in this step. That step will be doing later on. Now balance other all terms except hydrogen and oxygen. So here manganese is there. So manganese on the left hand side, it is twice. So we need to write twice on the right hand side for balancing the Mn. Here sulfur on the left hand side, it is 5 times. So we have to write 5 in order to balance the sulfur on the right hand side. So here in this stage we have balanced all the terms except oxygen and hydrogen. Now our aim is to balance this equation by balancing the oxygen and hydrogen. So first we have to do the balancing of oxygen. Till here, whatever steps we have done, that is same for the basic medium also. Only the changes comes in the balancing of oxygen and the balancing of hydrogen. So till here, it is the same methods, same steps which we have to follow in order to do the balancing in the basic medium also. Now there is a changes for balancing of oxygen and hydrogen. Now in the acidic medium, how to balance the oxygen? So better find it out how many number of oxygens are there on the left hand side and the right hand side. So when you find it here, it is twice MnO4 negative, that means 2 here, and 4 oxygen are there. So that means how much oxygen are there here? That is 8. 8 oxygen. Now plus here 5 is there and here 2. That is 5 into 2, 10. 10. That means the total how much it is? 18. Now what about on the right hand side? On the right hand side, because here 5 is there and 4. 4 oxygen, because we are finding out the number of oxygen on the right hand side. So 5 is here as a stoichiometric coefficient and 4 oxygen is there. Therefore 5 into 4, that is 20. So on the right hand side the number of oxygen is 20. On the left hand side the number of oxygen is 18. So in this step you have find it out how many number of oxygen are there on the left hand side and on the right hand side. Now find it out, are they equal? No, because on one side it is 18, on the other side it is 20. So you have to add the number of water on the deficient side. And how much is the deficiency here? Because here 18 and here it is 20. So how much is required now? 2 more it is required in order to equalize the left hand side and right hand side, the number of oxygen. It get equalized when we add 2 oxygen. So we have to add 2 number of water. That is important here for balancing of oxygen. First find out the number of oxygen on the left hand side and right hand side, and how much is the deficiency that you have to find out. How much is the deficiency here? That is twice number of oxygen is deficient on the left hand side. So that much number of water we have to add it on the same side where it is the deficiency. So there is a deficiency of 2 oxygen on the left hand side, that is on the side. So we have to add the twice water on the left hand side. That is for balancing of oxygen. Now when you find it out, the number of oxygen on the right hand side and left hand side, it is equal now. So that is the balancing of oxygen, which we have done it here by adding the twice water that is on the deficient side of oxygen. How much is the deficiency? 2 oxygen is deficient, that's why we have added 2 water. Now next is the balancing of hydrogen. In order to do the balancing of hydrogen, we have to find it out the number of hydrogen on the both the side, that is on the left hand side and on the right hand side. On the left hand side, when you find it out here, how much hydrogen is there? Because here there is no hydrogen, here only hydrogen is there. That means 2H2O, that is 2 into 2, that is 4 hydrogen is there on the left hand side. And what about on the right hand side? On the right hand side, 5 HSO4 negative, that means 5 H is there. Here the number of hydrogen on the left hand side and right hand side are not equal. So what we need to do? We have to equate these numbers. So how we can equate this number? When we add 1 here, at the time left hand side and right hand side, the number of hydrogen will be equal. So here there is a deficiency of a single hydrogen on the left hand side. That means according to the rule, what we have to add? We have to add H positive. We have to add H positive on the deficient side. It is not necessary that always we have to add on the left hand side. Where is the deficiency? There you have to add H positive. And how much is the deficiency? That much number of H positive should be added. So here a single H positive we have to add it on the left hand side, that is the deficient side of hydrogen. So when we add here H positive, that is a single H positive when we add on the left hand side. Now when you find it out that the hydrogen number is balanced, because 2 into 2, that is 4 plus 1, that is 5 hydrogen on the left hand side, and here it is 5 number of hydrogen on the right hand side. Therefore the number of H is balanced, as number of O is already we have balanced, and number of Mn, number of S, it is already balanced. So when you find it out here, all the terms are balanced. So this is the balanced equation. This one is the balanced equation. So in the exam you will be getting a question like this. You will be getting a equation which is without balancing, it is given to you. You have to balance it by this method. And the medium which will be given here, because here the medium is given acidic. So as I told you, acidic medium, this is we have explained for the acidic medium. Till the balancing of all other terms, the steps are same for acidic and basic. Only the difference is there in the balancing of oxygen and hydrogen. So in the next video we'll be discussing the balancing of any redox reaction in the basic medium. It is one of the most important type of question which will be definitely one question will be there in this area in the examination. So some of the equations I will be sending through images. So follow that examples also. So this is all about this video. Have a nice day.